Let's solve October-November 2019 paper 1-1. So we have first question, for which quantity is the magnitude of the reasonable estimate? So we have four options: frequency of a radio wave, and mass of atom, Young modulus, and the wavelength. So let's check. Well, for the frequency of a radio wave, for a radio wave, the frequency lies between the region 3 kilohertz to somewhat 300 gigahertz. So this answer does not fall in that range. What about the mass of an atom? Well, you know that the mass of an atom, it has into 10 raised to power minus 26, right? What about this? 500 micrograms is only, this is 10 raised to power minus 26 kilograms, and this is only into 10 raised to power minus 6 grams. So this does not fulfill the condition. Then we have Young modulus of a metal, and that is 500 kilopascals, but this is also not within the range, as because for steel you have 215 gigapascals, and for aluminum it's around 70 gigapascals. So this is too low, so this does not fall in the range as well. What about the wavelength of light? 500 nanometers, right? So we know that the light wavelength is in 10 raised to power minus 9, and so 500 nanometers sounds right. So the answer is D. Let's move on to question number 2. The speed of the wave in deep water depends on its wavelength L and the acceleration of free fall G. So we need to tell what is the possible equation for the speed v of the wave. So to go about this question, what you do is you do dimensional analysis and you check which expression or the equation is dimensionally correct. So let's pick one equation, and let's start with A. So you have G is, the units for G are meters per second square, right? And for L it is meters, and then you have the square root of these two quantities. So let's put them in. So you have meter per second square times meter. So this is meter square per second square root, and this is simply meter per second. So A is the correct answer because velocity has units meters per second. Moving on to question number 3, we have two vectors x and y, and we are given that if x is equal to y minus z, which vector represents the vector z? So we can write this equation as y is equal to x plus z. So now we have x and we have y. So what do I add to x to get a resultant y in this direction? So this is my x and this is my y. So I have to add something like this, right? So that means that the vector z is answer number A, right? Moving on to question number 4, we see that a student intends to measure accurately the diameter of the wire, which is known to be approximately 1 millimeters, and the internal diameter of a pipe, which is approximately 2 centimeters. So we are asked to see what are the appropriate instruments to make these measurements, right? So we are given calipers and micrometer. So, well, we know that the micrometer is an instrument to make measurements within a millimeter range. So the diameter of a wire should be measured using a micrometer. But what about pipe? So we know that vernier calipers is used to make the measurements of internal diameter, external diameter, and even depth, right? So the correct option is option number C. So we use micrometer for wire and pipe for calipers. Moving on to question number 5, the power dissipated in a resistor of a resistance R is calculated using this expression, and we are given the percentage uncertainty in V and R. So we have 5% in V and 2% in R, and we're asked to compute the percentage uncertainty in P. So we use the expression which is delta P by P is equal to 2 times delta V by V plus delta R by R. And now putting in the values in this expression, you have 2 times 5% plus we have 2%, right? So what do you get? You get 12%. So the correct option is option number D. Moving on to next question. The velocity time graph for an object with given mass is shown below, and we are asked to compute the resultant force that is acting on the object. So what is force? We know that force is given as mass times acceleration. But what is the gradient of this graph? Well, the gradient of velocity time graph is acceleration, right? So what you do here is you pick 2 points on this graph and you find the gradient of this, and then you multiply it with m. So the gradient of this, the slope of this graph is going to give you the acceleration. And to do that, you simply do take 2 points. Let's take 12, this one. So you have 12. You have let's pick another point, that is let's pick this one, which is 3, divided by what is time over here, 15, and what is time over here, 0. So you get and you multiply this with the mass, 2.5, and when you put these answers in your calculator, you get 1.5 newtons, right? So what is the correct option? It is C. Question number 7 says, which statement follows directly from Newton's first law? So what do we know from Newton's first law? We know the statement of the Newton's first law is something like that: a body is going to remain at rest or a constant velocity unless there is some net force that is acting on the object, right? So if you look at all these options, the only option that makes sense is option number A, right? So it matches exactly with the Newton's first law, also known as the law of inertia. Question number 8 says, a resultant force causes an object to accelerate. What is equal to the resultant force? Well, we know what is a force, right? Force is mass times acceleration, but it is also written as the rate of change of momentum, dp by dt. So the correct option in this case is option number C, the change in momentum of object per unit time. Question number 9. A skydiver falls from an aircraft that is moving horizontally. The vertical component of the velocity of the skydiver is v, and the vertical component of the acceleration is a. We are asked to tell which row describes v and a during the first few seconds after the skydiver leaves the aircraft. So let's see what happens when the skydiver will leave the aircraft. It will have some velocity, and you would expect that it will the skydiver will fall, and the acceleration would be, the only acceleration would be acting as g, right? Gravitational acceleration on the skydiver, and therefore the velocity must be increasing due to that acceleration. And so you might think that acceleration is constant and velocity is increasing, but think about this: there is air resistance as well, right? So the air resistance is going to cause the skydiver to decelerate as well, and therefore the deceleration would also be acting on the skydiver, which would basically decrease the constant value of g, and therefore the velocity would be increasing, but the acceleration, net acceleration, would be decreasing. So the correct option is option number D. So in question number 10, we have two gliders that are moving towards each other. Each glider has different mass and different velocities. So we are asked to tell about the speeds of two gliders after the collision, and we are known that the collision is perfectly elastic. For a perfectly elastic collision, we know that momentum and the kinetic energy both are conserved. So let's use the conservation of momentum, from where we'll use the expression where the relative speed of approach is equal to the relative speed of separation. So, and that equation is u1 minus u2 is equal to v2 minus v1. And so we have u1 is 1.2 meters per second, u2 is minus 1.8 meters per second, is equal to v2 minus v1. So we don't know what v2 and v1 is, right? And so this gives me v2 minus v1 equals 3 meters per second. So I've chosen the coordinate systems as though this right hand side is positive direction and the left hand side is negative direction. So we know that the difference in the two final velocities is 3 meters per second. And what is the other thing? We know that the kinetic energy should be conserved. So we'll use the expression half m Vi squared is equal to V1 squared is equal to half mv final squared, right? So the only condition that satisfies the only choice that satisfies these two conditions is the option number C, right? So 2.8 plus 0.2 is 3 meters per second. Question number 11, we have an object of weight W and it is suspended from a Newton meter, and when the object is completely immersed in water, the Newton meter reads P, and when it's completely immersed in oil, it reads Q. So we know the Newton meter measures the upthrust force. So for first diagram, the upthrust force will be equal to W minus P, and for the second diagram on the right hand side, it would be W minus Q. And we know that the density is proportional to the upthrust force, and therefore the correct option for the ratio of density of oil to density of water would be, for oil it's W minus Q, and for water it's W minus P. So the correct option is option number D. Question number 12 says, which diagram shows a couple? So we know that a couple has three characteristics. So one of them is the forces have to be of the same magnitude, the directions must be opposite, that's the second one, and the third one is that the line of action of these forces must not coincide with each other. So we see that this one, we have the line of action and they are parallel to each other, they do not coincide, and the forces have same magnitude F, and they're both opposite to each other. So the correct option is option number A. Question number 13, we are given an object of 120 Newton and it is supported in equilibrium by two strings as shown in this figure, and we are asked to compute the tension T1 in the left string. So because it's in equilibrium, we can use over here what is known as the force balance. So the forces in x direction would be equal, the sum of the forces in x direction would be 0, and the sum of the forces in y direction should also be 0. So the net force is on this object is 0, which means that if I have this as T2, then if I break it into components, this component, the horizontal component, is T2 cos 20, and the horizontal component of this one will be T1 sine cos 70. So equating the two gives me T2 cos 20 equals T1 cos 70, and this gives me a relation of T1 in terms of T2, or T2 in terms of T1. So I'll have cos 70 over cos 20, and this gives me T2 equals 0.36 for T1. Next, what I can do is I can use the force balance in y direction, which says that I would have T1 sine 70, because this is the vertical component T1 sine 70, and this is the T2 cos sine 20 vertical component for T2, and then equating these two. But you cannot really just equate these two, because both of these components are in upward direction, and then you have also one in the downward direction. So I'll add these two and they would be equal to the downward component. So that's T1 sine 70 plus T2 sine 20 is equal to 120 newtons. So this just gives me T1 sine 70, but what is T2 in terms of T1? It is 0.364 T1, and I have sine 20, and what is this equal to? 120 newtons. So just factor T1 out and solve the rest using calculator, and you would get 113 newtons for T1. So the correct option is option number C. Question number 14, we have a large container in oil refinery, and there are three different oils with different masses and different densities, and they're mixed, and we are also given that no chemical reaction occurs, right? So that means that the masses and everything would not change. So we are given these masses of these oil, and we're asked what is the density of the total mixture. So one way to solve this problem is to calculate the entire volume that is occupied by each of the three oils and then add them to get the total volume, and then using the density we can find volume 1, volume 2 and volume 3, and then using the total mass of these and dividing it by total volume we can find the total density. So let's use V1 for the first one. So we have mass 1 divided by density 1, which is 1200 kilograms, divided by 1100 kilograms per meter cube, and this is 1.0909. Similarly, compute V2, which would be 1500 kilograms divided by 860 kilograms per meter cube, and this turns out to be 1.744 meter cubes, right? And V3 is equal to 4000 divided by 910, which turns out to be 4.396. Now just find the total mass, which is M1 plus M2 plus M3 is the total mass, and volume is V1 plus V2 plus V3, which is the total volume. And then now to find the total density, you just divide mass by volume. So when you add all of these masses, 1200 plus 1500 plus 4000, you get 6700 kilograms, and dividing it by the total volume of the mixture, you just add these volumes and you get 7.2309 meter cube. Now just divide this expression and you get 927 kilograms per meter cube. So the correct option is option number A. Question number 15, we have an electric motor which produces 120 watts of output power, and the efficiency of the motor is given to be 60%. Which row is correct? We have electrical power input and we have waste heat power output. So we know the efficiency is given as the useful output power divided by the total input power times 100. So we have the efficiency, which is 60%. The useful output power is 120, and the input power is what we want to compute, right, as the electrical power. So we have some, let's just put X, and the value of X is, if from this equation it turns out to be 200 watts, right? So the correct option for electrical power output is 200 watts. What about the waste heat, right? So we just take this 200 input and subtract from this the 120 watts of useful power, and you get 80 watts, right? So the correct option is option number D, with 200 electrical power output and 80 waste heat power. Question number 16, a fixed amount of gas undergoes a series of changes to its pressure and volume, and you can see that these changes are represented in the PV diagram over here. Now we know that in two of the changes no work is done by or on the gas. In one of the change, work is done by the gas on its surroundings, and in another, work is done on the gas by its surroundings, right? So we are asked that during the change, when work is done on by its surroundings, how much work is done on the gas, right? Okay, so looking at this diagram, we see that there are four series of changes, right? So you have this one, you have this one, and you have these two, right? So work done by or on the gas is 0 when there is no change of volume, right? So you can see that if there is no change in the horizontal axis, then the work done is 0, which is on these two lines, right? So here work done is 0. And we know that the work done by the gas on its surroundings is during when the gas expands, right? So when the volume is increasing. So we know that is from this point to this point. So this line represents the work done by the gas. And similarly, work done on the gas is when the gas is compressing, which is represented by this line, where the volume, you can see on the horizontal axis, is decreasing from 5 to 2. So to compute the work done on the gas, we'll use the expression P times V, or in this case it would be P times change in volume, and the pressure so which one should be used, right? We'll use the compression region, which is from going from 5 to 2, and the pressure in this case is 1.0 into 10 raised to power 5. Don't forget that. So you have 1.0 into 10 raised to power 5 pascals times the change in volume. So it's going from 5 to 2. So we have 5 minus 2, but you also have into 10 raised to power minus 4 meter cube. Now put this in calculator, and the work done comes out to be 30 joules. So the correct option is option number C. Question number 17. An object traveling with the speed of 10 meters per second has the kinetic energy 1500 joules, and the speed of the object is increased to 40 meters per second, and we are asked to compute the new kinetic energy of the object. So we know that the kinetic energy is given as half mv squared, and the only unknown variable is the mass in this expression. And we have kinetic energy as 1500 joules. This kinetic energy is for the velocity 10 meters per second. So we'll have 10 squared, and mass is unknown. So we have, this thing becomes 1500 joules is equal to half into 100 times m. And if you compute for m, you get m turns out to be 1500 divided by 50, which is 30 kilograms. Now you can use this and put the new speed is 40 meters per second. So the new speed is 40 meters per second, and use the same expression for the kinetic energy. You have half into 30 kilograms into v squared, which is now 40 into 40. So this turns out to be 24,000 joules. So the correct option is option number C. So the next question is that the engine of the car exerts a force 600 newtons in moving the car 1 kilometer in 150 seconds. So we are asked to compute the average useful output power of the engine. So we know that the expression for power is force times velocity. But what is velocity? It is distance per unit time. So this is the expression for power. Now we are given force, which is 600 newtons. We are given distance in kilometers, so that's 1 into 10 raised to power 3 meters, and we're given 150 seconds. So when you compute this, you get 4,000 watts. And so the correct option is option number B, because it's 4 kilowatts, which is 4,000 watts. Question number 19, we're given an extension force graph for a spring, and we're required to compute the spring constant of the spring, which is K, right? So we know from Hooke's law that the force is directly proportional to the extension E, and from this I can solve for K, which is force over extension. So the gradient of this graph, the inverse gradient of this graph, is the answer for spring constant, right? So for force, let's pick the value 6 newtons, because the force is on the horizontal axis. So we have 6.0 newtons divided by the extension, in this case is 15 centimeters, right? So what is 1 centimeter? That is 15 into 10 raised to power minus 2 meters. So when you compute this, you get 40 Newton per meter. So the force constant is 40 Newton per meter, which is option number D. Question number 20, we're given a wire is extended by a force and the graph shows the extension of the wire varying with the force applied. We're given initially a force W gives an extension of D, so which is this part right here, and then it is increased to 2W, and this will increase the extension to 2D, right? Okay, so we are asked which area of the graph represents the work done by the force when the force increases from W to 2W. Well, we know that the work done is given by area under the graph of a force against extension. But note over here that the graph is inverse, right? So we have extension against force. So that's one point. So therefore, for the work done in the W graph, it is actually the area of the triangle OMT, right? So it is this area, right? Because force is on this axis and the extension is on that axis. Similarly, in the 2W graph, it is the area of the triangle OR and S, right? This one. So this entire area. And therefore, to find the work done, that is when the force increases from W to, so the work done to increase the force from W to 2W, it would be the difference between these two areas, which would be the region T, M, R, and S, right? So this region. So the option is option number T. Question number 21, you're given a transverse wave which is on a rope and have a wavelength lambda and period T. And we're given a graph that shows how displacement varies of the particles on the rope with distance of direction of travel of the wave at time t equals 0. So the direction of travel is to the right and a particle x is labeled at this point. Which graph shows the variation of displacement of the particle x with time t? So we know that when the particle x is at the position where displacement is equal to 0, so that means B and D cannot be the correct option because you see the displacement is non-zero in both these cases. And what about from A and C? Well, we know that the wave is traveling to the right direction, right? So the initial movement of the particle must be downwards. So the graph C is the correct option, right? So it should be downwards like this. Problem number 22, which statement about all types of transfer waves is correct? Let's start with the first one. They all have same speed, so we know that's obviously wrong. They all do not have the same speed, and they all have vibrations that are parallel to the direction of propagation. No, that's not correct because we know that they're not parallel, but they're actually perpendicular to the direction of propagation of energy. They all can form stationary waves, so that's correct, right? So all transverse waves can form stationary waves. They all can travel through a vacuum. Well, obviously not true because mechanical waves, for example, they cannot travel through vacuum, they require a medium. So the option C is correct. Problem number 23, we have a source that emits microwaves with constant amplitude, right? So S is going to throw microwaves with constant amplitude, and these microwaves are going to hit this metal screen P and they are reflected back, and therefore a stationary wave is formed between S and P. The wavelength of the microwaves is much smaller than the distance between S and P, right? So lambda is very small compared to the distance between S and P. A detector Q is moved at a slow constant speed from S to P. What happens to the amplitude of the signal that is detected by Q? Well, we know that the amplitude of the signal detected by Q will increase and decrease regularly, and that's due to the fact that the presence of nodes and antinodes are there, right? So that is due to the superposition of stationary waves that are formed between S and P. So the amplitude of the signal that is detected by Q should increase and decrease regularly. So the answer is B. Question number 24. The siren of a moving police car emits a sound wave with some frequency 440 Hz, and a stationary observer hears the sound frequency at 494 Hz. The speed of the sound in air is given, which is 340 meters per second. What could be the speed and the direction of the movement of the car? So this is a problem from Doppler shift, and we know that the expression for Doppler shift is given as f prime equals v plus vo by v minus vs times f, right? So we need to find the velocity of the source, which is the car that is emitting the sound wave. So we need to factor out vs from this expression. So putting the values, you get 37 meters per second towards the observer. 25. An electromagnetic wave has a wavelength of 138 picometer in vacuum. To which region of this electromagnetic spectrum does this wave belong? Well, we know that X-rays belong in the region which is from 10 picometer to 10 nanometer, right? So which means that 138 picometers should lie within the X-rays range. So the correct option is option number D. Problem number 26. Two wave pulses are traveling towards each other on a long rope, and the pulses have the same amplitude and wavelength and are traveling at a speed 0.5 meters per second. And this diagram shows the rope at some time t equals 0, right? So initially, and the velocities are shown over here. Which diagram shows the rope at time t equals 3 seconds? Well, at t equals 3 seconds, the both waves from the right and left will travel in their directions, and the crests and the troughs will meet, causing a type of interference which is known as the constructive interference, and therefore that wave looks like a wave in diagram C. So the correct option is C. Water waves of wavelength lambda are incident normally on an obstacle with a narrow gap, and the width of the gap is equal to the wavelength of water waves lambda, right? The waves from the gap emerge over an angle theta as shown, and we said that the gap is slowly widened. Which changes, if any, occur to theta and to the wavelength of the emerging waves? So we know that to have diffraction, the width of the slit opening must be equal to or at least less than the wavelength of the water waves over here. So when the size of the gap is increased, the diffraction will be actually less observed, right? And angle theta will decrease as well, obviously. So the amount of diffraction that occurs decreases, and it causes theta to decrease, but wavelength will not be affected, right? Every time the waves undergo diffraction, the wavelength still remains constant. So that means that theta will decrease and the wavelength remains the same. So the correct option is option number A. So question number 28. Light of wavelength 720 nanometers from a laser X is incident normally on a diffraction grating, and the diffraction pattern is observed. Light from a laser Y is also then incident normally on the same grating, and the third order maximum due to laser Y is seen on the same place as the second ordered maximum due to laser X. We are asked what is the wavelength of the light from laser Y. So we know an expression for diffraction grating, right? It is d sine theta is equal to n lambda, and we will rearrange this so that sine theta is equal to n lambda over d. Now the third order maximum of Y is seen at the same place as the second order maximum of X. So for X we have sine theta, is equal to sine theta for Y, and n lambda over d for X is equal to n lambda by d for Y. So this means that we would have second order for X, so that is n equals 2 lambda is equal to third order for Y, which is 3, n equals 3. So we'd have this expression over here, and so for Y we would have lambda is equal to 2 by 3 lambda for x, right? So let's just give these subscripts like this. And so we would have lambda y is equal to 2 by 3 of x, which is lambda x, which is given 720 nanometers. So compute this in your calculator and you would get 480 nanometers. So the correct option over here is option number A. 29. Monochromatic light of frequency f is incident on the diffraction grating of line spacing d and the speed of light is c. Which expression can be used to determine the highest order of intensity maximum produced by the grating? So we know that the highest order of intensity maximum produced by the grating is only achieved when we have theta is equal to 90 degrees, right? So what that gives me, sine of theta is equal to 1, because sine 90 it gives me sine of theta is equal to 1 because sine of 90 is equal to 1, which gives me lambda is equal to well, you know, you have lambda is equal to c by f, right? And using the diffraction grating equation on this, which is d is equal to n lambda, because sine theta is 1, this gives me n is equal to d over c over f, which gives me n equals df over c. So the correct expression over here is this one, which is option number B. Question number 30. We have a plate of metal and of uniform thickness, and it is connected to a cell as shown. So the electron flow is towards the left, and this is the metal plate when it's viewed from above. Electrons move clockwise around the circuit. Which statement about the metal plate is correct? So, well, the electron moves clockwise around the circuit, and which means that the current flows in anti-clockwise direction, right, due to the conventional current. And so the average drift speed of the conduction electrons will increase as they would move from right towards left through this metal plate. So what that means is we have 4 options over here. So the average drift speed of the conduction electrons decreases as they move. No, that's not true, right? As we discussed. The average drift speed of the conduction electrons increases as they move from right to left through the plate. So this is true, right? So the correct option is option number B. 31. The diagram shows the direction of the current in a metal block. The charge carriers enter the block through the face PQRS, as we can see, and they leave the block through the opposite face, right? So the number density of the charge carriers is N, and each charge carrier has some charge, which is E. The average drift speed of the charge carriers is V, which expression gives the current in the block. So you know the expression for current in terms of drift velocity is I is equal to NE VA, right, where E is the charge, N is the number of charge carriers, and V is drift velocity, while A is the area. So based on this diagram, the area is this face Y and this width X, right? So that's the area that is contributing to this current. So the area would be X times Y, and so the equation becomes I is equal to NEVX times Y. So that's the correct option, which is option number B. 32. What could not be used as a unit of potential difference? So we'd have to see what are the possibilities for the units that can be derived for potential difference. We know that the potential difference is given as I times R, V is equal to IR from Ohm's law, which gives you I amperes and R ohms, right? So the units for these are this. Then you have potential difference is P over I, which gives you units watt per amperes. And then we can also have potential difference V is equal to square root of P over R, right? And this gives me units ohms watt raised to power. Now we have amperes, ohms, right? So this one is true. We have watts per ampere, so this is true, and this is also true. What about this one? So this is not true, so this cannot be used as a unit of potential difference, so this is the correct option. Moving on, 33. Which graph could show how the resistance R of a filament lamp varies with the applied potential difference as V is increased to the normal operating potential difference, PD? Right, so we have these graphs, and we know that the behavior of a lamp is as when the applied potential difference is going to increase, the current will eventually increase, and this will make the filament lamp, which is getting hotter, and it will cause the resistance of the lamp to increase because the filament lamp is getting hotter, right? So that means that the correct option in this case would be option number A. Thirty-four, Kirchhoff's two laws for electric circuits can be derived by using conservation laws. On which conservation laws do Kirchhoff's laws depend? So we need to know what are the Kirchhoff's first and second laws. So let's quickly recall. The first law is actually also known as the current law, and it states that when the current is flowing into a node, or sometimes also known as junction, it must be equal to the current that is flowing out of that junction. And this leads to the conservation of charge, right? So charge is conserved from the first law. Next, we have Kirchhoff's second law, which is also known as the voltage law, and it states that the sum of all of the voltages that are around any closed loop in a circuit must vanish or be equal to zero. And this just leads to the law of conservation of energy. So Kirchhoff's second law tells you about the conservation of energy. So first law tells you about the charge, and second about the energy. So the correct option is option number B. Moving on to question number 35, we have a circuit, and we're asked about which statement of the circuit is not true. So let's start from A. We have electromotive force is the energy transferred per unit charge. So we know that's true. B. Energy is transferred from chemical potential energy in a cell to other forms when the switch is closed. That is obviously true. And C. The electromotive force of the cell is greater than the terminal potential difference when the switch is closed. So we know that's true as well. So when the switch is open, the voltmeter measures the electromotive force of the cell. Well, that's incorrect, right? Because when the switch is open, there is no measurement taken as the circuit is incomplete. So the correct answer to this is option D. Right, so next we have this problem number 36, and the diagram shows a circuit that contains 4 voltmeters, and the readings on the voltmeters are V1, 2, 3, and 4. All of these readings are positive, and we're asked which equation relating the voltmeter readings is correct. So let's solve this part, right? So for the parallel circuit, we have this one, that is V1, and this is equal to V2, right? So these voltage parallel would be equal, and this would be equal to the sum of these two, right? So we would have V1 is equal to V2 is equal to V3 plus V4, right? And so this gives me three different expressions, which is one is V1 equals V2, and we have V1 equals V3 plus V4, and V2 is also equals to V3 plus V4. So we have these three expressions from this one, and now we can rearrange the last one, which gives me V3 plus V4 minus V2 is equal to 0, right? So we have just rearranged this one. And so this, we have this option is option number D. So that's the correct one. Question number 37, we have a network that consists of a 3 ohms resistor and a 6 ohm resistor, two 6 ohm resistors, which are shown in this figure. So the potential difference across the network is also given as 4 voltage. And what is the current through the 3 ohms resistor? So to compute that, we would first need to know what is the total resistance of the circuit. So we have this one, and we have these two in parallel. So these two parallel, we can sum those as 1 by 3 plus 1 by 6 inverse, and then we can add that in series to the 6 ohm resistor. So that gives me 8 ohms. So the current in the circuit is then given by I is equal to V over R, and we know that V is the difference across the network, which is 4.0 volts, and R we just computed as 8 ohms. This gives me 0.5 amperes current. So the potential difference, now we need to find the potential difference across the left 6 ohm resistor, which is this one, and we'll use the potential divider. So we would have 6 over 8 into 4, 6 over 8, so the total resistance is 8 and 4 voltage, right? So this is the potential divider equation, and this gives me 3 voltage. So now the potential difference across the parallel resistors is 4 minus 3, which is 1 voltage, right? This is the potential difference across these two parallel resistors, and the current through the 3 ohm resistor is then very simply V over R, which is 1 volt divided by the 3 ohm resistance, which is 3, which is 0.33 amperes. So the correct option is option number C. Next we have this circuit in question number 38, and all the resistors are identical and all the ammeters have negligible resistance. We're given that the reading on the ammeter 1 is 0.6 amperes, and we're asked what are the readings on all the other ammeters, right? So we know that if the reading on ammeter A1 is 0.6 amperes, and so let's just write that down, this is 0.6 amperes, we can use Kirchhoff's second law in the first loop of this circuit, right? And applying Kirchhoff's second law, we would have 0.6, which is I, times R, plus again 0.6, which is going in there, 0.6 times R, and this is equal to the EMF. This gives me 1.2 times R is equal to E. Now in the A3 branch, this resistor is in parallel with the EMF, and so using Kirchhoff's second law in the second loop of this circuit, we have IR is equal to E, but E is 1.2 times R, which gives me current as 1.2 amperes. So in A3 we would have, this is for A3, right? So we'd have 1.2 amperes, and the two identical resistors in the A1 branch, these ones, they are in parallel with 3 identical resistors in the A4 branch, these ones, right? So you can see that they're parallel. So the reading on A1 we know is 0.6 amperes, so the reading on A3 is twice times 0.6, right? So we can see that, right? So it is 0.6 times 2, which is 1.2, which is what we got from here. And the reading on A4 would then be 1/3 of the reading that is on A3. So this is 1/3 of 1.2 is 0.4 amperes. So the total current in then this circuit is to be 0.6 plus 1.2 plus 0.4, which turns out to be 2.2 amperes. So the correct answer to this expression, to this question over here, is option number D. A2 is 2.2, A3 is 1.2, and A4 is 0.4. Question number 39. An unstable nucleus of an element, it decays by emitting an alpha particle or a beta particle to become a nucleus of a different element. This nucleus is also unstable and also emits an alpha particle or a beta particle. The process continues until an isotope of the original element is produced. What is the minimum possible number of these particles emitted? Right, so we'll have to do some working, so let's get some space. Now, okay, so let's suppose that the unstable nucleus has some mass number A, right? So this is for unstable nucleus. This is the mass number, and it has some proton number Z. So this is the proton number. Now, the first possible reaction is that the nucleus will emit a beta particle and it will become a nucleus of a different element, right? And so the resulting would be a mass number and an increase of 1 in proton number, right? So the mass number would be same. It would result in the same mass number, but proton would increase, right? Because it's a beta minus, beta decay. So that means that A remains the same from this decay and Z gets an increment of 1. What about another reaction, which is that the nucleus of the element would emit beta particle and it would become a nucleus of a different element, right? And so this would also result in a same, so let me write it down, beta decay for a new nucleus, and it would also result in same mass number, but atomic number would increase by 2, right? Because it was already increased by 1 from here, and so it increases by 1 more, so that's 2. So now the minimum number of processes could stop over here when the final nucleus will emit an alpha particle now, and it would result in a decrease of its mass number by 4 and the decrease in proton number by 2, right? Because alpha has mass number as 4 and it has proton number as 2. So this is going to produce an element that would be an isotope of the original element, and so we would have, by alpha decay, we would have the mass number would decrease by 4 and the atomic number or the proton number would remain Z, right? Because we had, this is what we had from the first beta decay, then we had second beta decay, and that became Z plus 2. Now we would have Z plus 2, and because of alpha particle we would have minus 2, so this becomes Z, right? So the process will end whenever an isotope of the original element was produced, and so you can see that the isotope of the original element is produced. So the process ends over here, which means that there are 3 minimum possible number of these particles that would be emitted. So the correct option is B. Okay, so the final question, question number 40, we have diagrams which show quark composition of 4 different hadrons. One of the hadron is a sigma plus particle and it has a charge of plus E, and the E is the elementary charge, we all know that. Which hadron could be the sigma plus particle? So we have to compute the total charge of these, and if for whichever particle it turns out to be plus E, that could be the sigma plus particle. So we know we have the charges for quarks, different quarks. We know that the up quark is plus 2 by 3 e. We know that the down quark is minus 1 by 3 e, and this s quark, strange quark, it is plus 1 by 3 e. So to find the charges on these quarks, let's try with the last one, right? This one. So we have U, and S. So the charge on this one would be plus 2 by 3 E plus 2 by 3 E, and for the strange it is plus 1 by 3 E. So we see that this gives me 2 plus 2 is 4, plus 1, 4 plus 1, 5. So this gives me 5 by 3 E. What about USS? So that's 2 by 3 E plus, well, S is 1 by 3, so plus 1 by 3 E plus 1 by 3 E. So this gives me 3, 4, 4 by 3 E, right? So this cannot also be the answer. Then you have DSS, which is down quark is minus 1 by 3 E, and S quarks are plus 1 by 3 E plus 1 by 3 E. So this gives me 2 by 3 minus, so this goes with this, and this gives me 1 by 3 E. How about D, and S, right? So this gives me minus 1 by 3 E minus 1 by 3 E plus 1 by 3 E. Right, so actually there is a problem over here, and that is in the strange quark, right? So that's not plus 1 by 3 E, that's actually minus 1 by 3 E. So let's fix that very quickly. Right, so now let's try this one. You have UUS, right? So that's 2 by 3 E plus 2 by 3 E minus 1 by 3 E. So this gives me 3 by 3 E, which is equal to E. So this has the elementary charge E, and so therefore this UUS could be the sigma plus particle, right? So the correct option would be option number D.